This tutorial is for Mobius Assessment, Lesson 2, Homework Question Number 6, Making an Informed Decision Using the Quantitative Reasoning Process. Step 1. Understand the problem. Keep the old car or buy a used car. Manny is an online student who currently owns an older car that is fully paid for. He drives, on average, 130 miles per week to commute to work. With gas prices currently at $3 per gallon, he is considering buying a more fuel-efficient car and wants to know if it would be a good financial decision. The old car Manny owns currently gets 17 miles per gallon for average fuel efficiency. It has been a great vehicle, but with its age, it needs repairs and maintenance that average $670 per year as long as nothing serious goes wrong. The newer, more fuel-efficient car that he is looking at to purchase will cost a total of $6,500 over a 3-year loan process. This car gets 27 miles per gallon and would only require an average of $10 per month for general maintenance. To help make a decision, Manny wants to calculate the total cost for each scenario over 3 years. He decides to use the quantitative reasoning process to do this. The first thing I've done is I've given myself a spreadsheet and I've just gleaned all of the information over here on the right. I know that it told me miles per week was 130. The gas price per gallon was $3. Then I have how much for his old car and how much for his new car. The old car costs $0 because he owns this. It says it's fully paid for. Then miles per gallon, it gets 17 miles per gallon. Yearly maintenance was $670 every year, and we're going to find the cost over 3 years is what he's looking towards. The next was this paragraph here has all the information for the newer car. It costs $6,500 total over the 3 years, and miles per gallon, it gets 27 miles. And the monthly maintenance was only $10. And again, I left a space where we're going to calculate the cost. The next step, step number 2, identifying variables and key assumptions. Manny has identified some key variables for his situation. Select the 2 variables that should be removed from his list because they do not apply to this current situation. They might apply to another quantitative process or so forth. Okay, the first one. The year Manny was born. So, in understanding the problem, we're looking at an old car and a new car, and all of the calculations and everything's going to be about these cars, so that doesn't help us at all. The number of miles Manny drives each week. This is actually really important, and it helps us in our calculations later. The loan cost of the used car. No, that one is, again, a very good number we need to have for our calculations. Manny's wages. Now, while that's not over here, it is a good key variable because it will decide on whether he can afford his $6,500 car or not. The next one, the cost of repairs on the old car. Yep, again, this is going to help us with the final decision. And the next one, the cost of gas. Yeah, this applies to everything that we're going to be calculating for the cost of both of the cars. The cost of the used car. I think that was already on here. Oh, the loan cost of the used car and the cost of the used car. I'm guessing again here, the cost of the used car, which it calculates into the cost of the loan because that changes how much he's going to have to pay for the overall cost of the car. And the last one, Manny's graduation date from elementary school. Again, this does not apply to this situation. It might apply to something else, but it is not helpful in the key variables for this particular quantitative reasoning problem. So we selected 2 variables that should be removed. Now we can move to the next one, key assumptions. Manny has also made a list of key assumptions he will be using to make his decision. Check the boxes for the 3 assumptions from his list that are not useful in this scenario. Manny assumes that nothing will go seriously wrong with either car during the 3-year period. That's a really key assumption because if something goes wrong with either of them, then this definitely affects what what decision he would have made. So we're assuming that the old car will continue to drive just fine, and that all of this is going to stay the same for those 3 years. Same with this one, or our calculations mean nothing, right? So we're going to assume, along with Manny, that everything's going to be fine. Manny assumes that there are 52 weeks in a year, which is great because we need to find the cost of the 3 years, and assuming that we have 52 weeks is great. Manny assumes gas costs will remain about the same over 3 years. Again, because this is part of our calculations here, we can't, go in and make a bunch of variable changes and say, well, it's probably going to get more or less. We just have to decide and stick with it. And so he made that assumption that it'll be about 3. So that's great. Manny assumes that he will still like spinach at the end of 3 years, no matter which choice he makes. Again, I'm sure that this would make sense in another situation, but this isn't helping us in his calculations for his car. So I'm glad that he's going to like spinach, but it's not helpful. Manny assumes he will continue to go running in the mornings every weekday for the next 3 years. Again, a great assumption for him, but it's not helpful in working through all of the calculations for this particular problem. Both of those would be great assumptions for maybe a health-related quantitative reasoning. And the next one, Manny assumes his lunches will continue to cost about the same for the next 3 years. I'm going to say that some people would maybe say that that would affect his budgeting, but we're going to say that that's probably more applicable to a budgeting question versus this particular quantitative process. So we're going to select that one, but there could be something else, so we'll continue. Manny assumes he will continue to drive about the same number of miles each week over his 3-year period. Again, this is a really critical assumption here that if all of a sudden he has to quadruple this amount, that will definitely change how much both of these will cost because of the difference in the miles per gallon in fuel efficiency. So that is actually a really critical key assumption he needs to make. The next one, Manny assumes the loan period will be 3 years, which was already told to us, so that was great. It is, and we're going to find that cost over 3 years. So I think we found our 3 red herrings in there. Next one. Step 3 is apply quantitative tools. So we're going to use computational and algebraic tools to quantify the total cost using gas, maintenance, repairs, and purchase price for each scenario over 3 years. Round your answer to the nearest dollar. So the first thing we want to calculate here is how much he's going to be spending on gas. So we want to find out how many gallons he's going to be using per week, because we have miles per week, we have the price per gallon, we have miles per gallon. So we're just going to find out how many gallons he needs per week. So the first thing we're going to do is take his 130 miles, and let's go ahead and we'll do the cost associated with gas right here. So we're going to do equals so that Microsoft Excel will calculate for us. We'll take his 130 miles and then divide that by how many miles per gallon he gets, and that will tell me how many gallons per week he needs. And so this is how many gallons he's going to need per week. If we take this amount and multiply it by the cost, that'll give us the total cost associated with how much he needs to purchase, how much money he needs to purchase gas every single week. So we're going to multiply this by $3, and that's how much it costs him per week to drive his 130 miles. Now we will we need to find the cost over the 3 years, and we'll come back to that in just a minute. Let's go ahead and find out how much he needs for the new car. So again, we're going to take our 130 miles per week, divide this by his fuel efficiency, which is 27, and then again we'll multiply by how much it costs per gallon, and that will be only $14 every week. Now we need to find, so this is the, you know what, I'm going to go over one more. So this is weekly cost. So I'm going to put that there, and this we're going to do, let's find yearly, and then and then we'll multiply it all to get the 3 years. So here we have weekly, and he made the assumption we read earlier that there are 52 weeks in a year. And so we're going to multiply this by 52, and that will give us, oh, I'm so glad that happened. Every semester I get questions about these number signs. You didn't do anything wrong. It just means that your column isn't big enough for the number that you want to see in there. So this is how much it will take for his old car for an entire year. And if we want to find out how much it'll take for 3 years, we just need to take that and multiply it by 3. Same thing with this one down here. We'll enter equal, cell reference, one left click over here, times it by 52 weeks, and then times that by 3 years, and that tells me how much it'll cost in gas for the 3 years on both of those cars. Now we want to find the maintenance costs. So this one is a yearly maintenance. So I'm going to go straight here to year, let's change this. This is over 3 years. This is after 3 years because we ended up multiplying by 3. This one already gave me the yearly cost, so we're going to go directly to this column here and find how much it'll take for maintenance on this old car over 3 years. So I'm going to cell reference here and then multiply that by 3 years, and that will tell me how much for the old car. For the monthly maintenance here, we're going to go ahead and, I know this says weekly, but we already have monthly, so I'm going to find, yeah, we can go over here for the 3 years. We'll just times it by 3. So this is a monthly maintenance, so we need to multiply that by 12 to find out the total cost for an entire year, and then we need to multiply it by 3 for the 3 years for the 3-year period we're looking for. The cost here for the 3 years we know is $6,500. The cost here, he has it fully paid off, so it's 0. And now we have the cost of each of these items for those 3 years, and we can total it here. I'm going to drag this over just a little bit. There we go. Just so I can show the fast summation here. Pin this down. Okay, so I want to find the total of all of this for the old car. I can just press equals and then select each of these and add them. I can type in myself that I want to sum and open a parenthesis and then select one left click and hold, don't lift up, drag it down, and it'll add all of those together. Oh, and since I have that, might as well. And this one, I could also just come up here to the fast one. It's called auto sum, and it just adds it all up for you. So it's really fast. I'm going to go ahead and format these both as currency so that we can see that in dollar amount and compare the two. So for the old car, keeping his old car and not having any sort of payments except for the maintenance fee is $5,588, and at the end of 3 years with the new car it's $9,113.33. So we're going to actually, let's just copy and paste, Control C, come over here, Control V, and then I don't worry about any typos except that I already have a $ here, so I don't need to put the other one there. If I leave that, the computer program won't understand. By the way, to get out of that, you just press Enter. The computer program won't understand what you've done with the symbol, so it'll mark it as wrong if you leave the $ on. Again, Control C to copy and Control V here and take this off so that it will calculate or that it'll see the answer. And then let's go up and read the instructions. Round your answers to the nearest dollar. So I'm going to take off my 82 cents and round up the 8 to a 9. And the 33 cents, don't change that 3. So just take that off. Okay, make an informed decision. Based on the information present, what do you think Manny should decide? We could say option 1, keep the old car, or option 2, buy the fuel-efficient used car. With the numbers here, I'm going to say that Manny should go with the cheaper option, which is his old car. So I'm going to say option number 1. And the last, evaluate your reasoning. Manny plans to start looking at cars and will evaluate his reasoning before he makes any purchases. So another option he could do is find another newer car that would maybe cost less and maybe bring this down so it would make it a better fuel efficient car, or better efficiency for his entire budget. And what we've done over here using the Excel spreadsheet is pretty convenient, so that I can just change all of the original numbers that we were given, and it'll automatically change these over here because we cell reference, and I don't actually have to go through the calculation phase again because it's already there. So let's say he ends up increasing his yearly maintenance, something terrible goes wrong with his car, and this ends up being $800. Pressing enter will automatically change that for us, and we can see that it actually didn't change his overall a whole lot. If he found a better cost for an old car, I think I typed this one in. So right here, let's say he found one that was only $4,000 with the same miles per gallon efficiency, and it's actually still cheaper to go with this one. But that's kind of the benefit of using Microsoft Excel. The last thing is we can go up and just double check by how did I do, and make sure that all of those green check marks came up. It looks good. Got them all. Okay, so if you have any questions, feel free to contact me about this one. Good luck on your homework.